once again with all my previous students, and hope that this training program will give the more knowledge as similar to that of your previous program, that was ETABS RCDC Excel. So here this training program we have prepared for dealing only the substructure, dealing for foundation. Okay, so as you all know that in this training program we are trying to we will discuss all about the design of substructure. Different types of the foundations are there, like isolated foundation is there, combined foundation is there, raft, pile. So many things are there that we will cover for the design of substructure. Okay, so as you all know that in this training program there will be no discussion of the superstructure. Okay, very basic thing, very and you all have to understand about it. Thereafter, for the smooth conduction of this training program, and to avoid the disturbances, okay, and for better teaching and to maintain the scenario for the better teaching and learning, you all have to follow some instructions, some guidelines throughout this training program in every session. So very first thing will be what ki- it's a request with you all guys, don't ask any question which is not related to ongoing topic. Okay, it is creating the problem, it is creating the disturbance. So please, it's request with you all guys, don't ask any question which is not related to ongoing topic, very first and very important. Second thing, don't ask the question which will come on later stage, like some of students what they are doing in the first session or in any session. If suppose we are talking about the isolated foundation, raft foundation, and here he is going to he is asking about what, pile foundation. He is asking about suppose we are discussing about the combined footing, someone is asking about the raft foundation. So don't do this. Whatever the topic, yeah, that things will come later, or wait for the things that will come. Once the things is once the thing is completed and your doubt is not resolved, at that time you can ask. But most of the time students what they are doing, like topic is going some other topic is ongoing, and the students are asking some other topic. Or sometimes students what they are doing, they are having a very hasty, like the topic we will come later, they are asking that question in early stage. So don't do that every point, because you know my way of teaching, my way of conducting the things, I try to cover everything, but the sequence will be there. But the sequence will be there, one thing will be covered first, then we will move for the next step. Got it. Later on we will cover everything. So we will start everything from very basic, then we'll come to the advanced level. So these things you have to remember. Now third point, you need to remember that during the entire training or in every session, kindly mute your mic should be on mute condition unless and until it is required to unmute. Whatever your doubts, queries are there, you can put in the chat box. If I feel it is important to answer, I will definitely. If I feel to take it at the end of the session, we will take. Okay, so at the end of the session, discussion will be there. So, and whatever your doubts and queries, you can put there. Okay, so these all are some important instructions you all have to follow for the smooth conduction of this training program. Is that all okay?
Yes, sir.
Very good. Now, very first thing is here we have to talk about the design of foundation, design of substructure. Got it. But some basic concepts we have to clarify. See, sequence will be what? Try to understand. First, we will cover some basic concepts about the design of the foundation. So we have to set our mind that what we are going to do, and all the basic things we are going to cover first. Thereafter, we will take all the different types of putting design manually, along with Excel sheets, along with like validation of that all manual calculation with your safe software. So we are trying to do everything in sequence. So in this session, we are trying to understand some basic concept for the design of your foundation, for the design of your substructure. Is that okay? Now Let's see. Is it visible to all of you?
Yes, sir.
Okay. So very basic discussion will be there. Many of you may be aware, may have the knowledge about all those basic concepts, but some advanced thing you will learn from this discussion. Okay. So you know very well the load transfer mechanism for any structure is what the load is going to be transferred in the gravitational direction. The load of the superstructure is going to be transferred to the substructure. That is the basic concept. We all are aware with this. Okay, any kind of structure, if you are talking like residential building is there, commercial building is there, tower is there, whatever the type of the structure is there, the load transfer mechanism is same, load transferring direction is same. What the load will transfer from top to bottom in the gravitational direction. Very basic thing. If suppose if your structure is subjected to lateral load, so your lateral will also going to be concentrated at one point at any particular floor, and that is going to be concentrated from upper floor to the lower floor, or likewise it is coming to the foundation or substructure. So the very basic thing is what load transfer will be in the gravitational direction. But in our mind there is a myth that your foundation will carrying the load of the superstructure. Your foundation is carrying the load of the superstructure, so it is totally wrong. Your foundation is not carrying the load of the superstructure, and we are not designing the foundation to carry the load of the superstructure. So you may ask, means is it not possible? We are designing the foundation to carry the superstructure, we have learned this, so it is wrong. Your foundation is not carrying the load of the superstructure, but it is transferring the load to the subsoil, where the responsibility of this your foundation, try to understand, this foundation has the responsibility to transfer the stresses that is coming from the superstructure to the subsoil. Hello.
Yes, sir.
Okay, so here it is what whatever the load coming from the superstructure, that is first is going to be acting over your foundation, and foundation is foundation is responsible to transfer that load to the subsoil. The another myth in our mind is what like a foundation means we are giving the importance to the foundation. No, that is not right. Here substructure we are considering what your foundation only. No, that is not the right one. Substructure will include your soil mass along with your foundation. So soil mass and foundation will combines give you your substructure. Hello. So whatever the load that you are going to put over the foundation, it is going to be transfer that entire load to the subsoil. Then again the thing is what we are giving the importance to the foundation, but we are not giving the importance to your subsoil. We need to give the importance to the subsoil as equal as that of your foundation, because your foundation is not carrying the load, your soil is going to carry the load, and this soil we are going to call it as subsoil, and sometimes we are going to call it as subgrades. So whatever the load coming from your superstructure, it is going to be transferred to the foundation will transfer the load to the subsoil. Okay, so we need to take care about the strength, capacity, and we need to do a lot of study about your subsoil. Your subsoil should capable of carrying the load of the superstructure. Your subsoil should capable of carrying the load of the superstructure. Got it? And your foundation should also be capable of transferring the load safely to the subsoil. So overall, for the satisfactory performance of superstructure, there should be stable substructure. There should be stable substructure. Substructure will be what? Only the foundation? No. Your subsoil along with your foundation will combinedly will become your substructure. So for the satisfactory performance of superstructure, the stability of your superstructure, the strength and life of your superstructure is mainly depends on the substructure. Substructure means what? Your foundation and subsoil. Sometimes what happen, like your foundation will be safe, your foundation is stiff, your foundation is capable of transferring the load to the subsoil. it is very means a lot of stability is available for your foundation, but there is a settlement in your subsoil. So what will happen? There will be the collapse and there will be the settlement. There will be the possibility of instability of your superstructure. Got it? So for the stability of for the satisfactory performance, remember what terms I am using. For the satisfactory performance of your superstructure, we need to have the stable superstructure. We need to have this stable substructure. Is that all okay? Hello.
Yes, sir.
Okay. Now, second thing is what? Like in the current scenario, you know very well, there are so many challenges, there are so many competitions all over world. In respect of what? Like so many complicated superstructures are there. So many iconic structures. Every country they are going to they are going to create. Kindly mute your mic. Who is there? Hello. Okay, so in the current scenario, what there are so many complication and challenges for the superstructure, and to get the existence of that complicated superstructure, there is an option. We can build that superstructure. Like suppose we need to have the higher strength of the concrete, so that you can make that you can make. If you need to have very high strength of the glass, that you can make any kind of geometry you can make in the superstructure. Because what for building of your superstructure, is it possible to do anything? Because for the superstructure, the materials, the elements, that sections that we are using, that all are the man made. Hello. For building your superstructure, everything that we are going to use, that all are the man made. There's no anything that is the naturally we are going to take from the nature and we are going to put it in the superstructure. No, that kind of thing is not there. In the superstructure, like any kind of geometry, any kind of material, any kind of strength you can achieve. But when you come to the subsoil, there is a complication and limitations to manipulate the strength of the subsoil. Because your subsoil is what? Your subsoil is a natural element. Hello. Your soil mass is a natural element, and you don't have a what you don't have the command to manipulate the properties of your subsoil. Hello. You are with me or not? Am I audible?
Yes, sir.
Right, sir.
You're audible.
Okay, so
Yes,
if
sir.
you are talking about the subsoil, so your subsoil is what? It is a natural element. If suppose for the superstructure I need to have 1000 kilonewton or newton kilonewton, just for example, meter square over the area strength, so that I can get. But when you come to the subsoil, if you want to have very high strength bearing capacity of the soil, so that you can't achieve. Some of you may say that we can increase the strength of the subsoil, so that is also not possible. So very limited manipulation is possible for increasing the strength of the subsoil. You don't have a control to a greater extent to manipulate the properties of the subsoil, because it is a natural element. It is what the natural element. So that is what the complication with the soil mass. And that's why here we are not going to increase the strength of the subsoil, and whatever the strength we are getting, whatever the bearing capacity of the soil we are getting, accordingly we are going to decide the type of the foundation. If the soil so we will talk about it on what basis we are deciding the type of the foundation and depth of the foundation. That is all later discussion in detail we will talk about. The complication you need to understand, like you can't manipulate the strength or capacity or properties of your soil mass. And there are so many challenges are there to find out exact bearing capacity of your soil, exact capacity of the soil. And if you want to do the calculation, if you want to do the if you want to know the capacity of the soil, what so many assumptions you need to take. So many assumptions, without of making the assumptions, without of considering that assumptions, you can't find out the bearing capacity of the soil and you can't use the any equation. So in any approach for finding out the capacity of the soil or knowing the properties of the soil, we are going to make some assumptions, but that is not possible to get in actual. Very first is what, while making the calculation, like for the soil and for knowing the bearing capacity of the soil, what we are considering, soil mass is linear. Soil mass is what? Linear. Stresses development is linear, but in actual it is not linear. Like if you are going to load this soil mass, so the stresses is going to be developed in the soil mass is not linear. Whatever the load you are going to put, the stresses in the soil mass may be random, maybe of any value. So it will not happen that whatever the load that you are going to apply to the soil mass, accordingly the settlement or stresses in the soil mass is going to be developed. So this linearity is not there. This linearity is not there. Soil in actual is complicated. You can't predict the deformation of the soil mass, stresses development in the soil mass. You can't predict that. But while making the calculation, we are considering that the soil mass is linear. Soil mass is actually non-homogeneous. Soil mass is actually non-homogeneous, but while making the calculation, we are considering as soil mass is homogeneous. What does mean the homogeneous and non-homogeneous? Means the accumulation of the particles of the soil mass will be different, will be of different properties. It is anisotropic. It is anisotropic means whatever the load you are going to put over the soil mass, so there will be the disturbance to the soil mass or displacement in the soil mass will be in any direction. This is what anisotropic property. It is actual property, but while making the calculation we are considering it as what? Hello, isotropic. Hello.
Yes, sir.
The capacity of the soil or strength of the soil or parameters of the soil will be what? It is the time dependent. It is what? The time dependent. If suppose the capacity of this particular area of this particular soil is at this time is suppose 200 kilonewton, 200 kilonewton per meter square. After 10 years the capacity may be different, so it is time dependent. It is depends on the environment. Change with the change of the weathering conditions, with the change of the environmental conditions, your property and capacity of the soil is going to be changed. So you can't predict the actual one. So it is what, there are so many complications are there in the for finding the capacity of your soil, for knowing the actual capacity of the soil. There are so many other parameters are there based on that or according to that your bearing capacity of the soil or strength of the soil, your soil is going to be changed. Another thing is what, as you all know that if you look the soil mass, okay, so the soil, if you look over the depth, so there are different, below the ground level there are different layers of the soil mass. There are different layers of the soil mass. I will let you know in the geotechnical investigation report later on. Later on when we will study about the geotechnical report, soil investigation report, so you will come to know the earth mass when you move to the from ground to bottom or to a deep under the ground level. So what, the soils are in different layers. Here the clay may be there, here the stiff clay may be there, here the more stiff layer will be there. So likewise if you move below the ground level, so what, the density or stiffness of the layer, it is going to be increased. It is going to be what? Increase. The capacity of the soil is going to be increased if you are moving top to down from the ground level. So actually what will happen, like means while taking the sample from the sample, while taking the sample for the for finding the bearing capacity of the soil, for knowing the properties of the soil, what we are doing, we are taking the sample somewhere here, we are taking the sample somewhere here. So problem is what? We can't see the actual actual changes in the layer of the soil over a large depth. Because how we can look that? Who will show you the section of the soil, section of your earth mass to a greater depth? What we are doing from the top, we are taking what possible depth, we are taking the sample of the soil mass, but we are not going to take care about the depth of we are not going to take care about the property of the soil at a greater depth. So doing the study to a large depth by the layer wise, it is very difficult. It is what? Very difficult. And another, the most important parameters is there, that is creating the complication with the soil, subsoil, knowing the property of your subsoil is what? Your soil mass is very, very sensitive. Hello? The soil mass is very, very sensitive. Means what? Suppose you are taking your sample of the soil. Let's see. Suppose this area is there, and I'm going to take the sample of the soil mass from here. Sample of the soil mass I'm taking from here. So, suppose in section, if you are looking the soil, I'm going to take the soil from this pit. Soil from this pit. So when the soil is present on the ground, so here the bearing capacity will be different. Hello, here the bearing capacity will be different. Means what? Surrounding soil mass is there, so it is adding the stiffness to this soil mass. So here the bearing capacity will be more. Here the bearing capacity will be more. Like suppose I'm taking the sample out of this pit. I'm taking the soil mass. I'm taking the sample in ball. Okay, I'm going to take the sample. I'm carrying this sample in the laboratory, and there in laboratory I'm going to find out the bearing capacity and all other parameters for knowing the capacity of the soil. I'm going to test in the laboratory. So just tell me, whatever the property of the soil was present on site, the same and exact value we will get in the laboratory. Hello.
Yes, sir.
No,
That is not possible. We can't say that whatever the property of the soil is on site, whatever the property of the soil on site is there, the same property and same strength, same capacity we will get in the laboratory. Am I right? Hello.
Yes, sir.
yes,
Here the strength and stiffness is very, very high because the surrounding mass is there. But we are taking only small portion and part of the soil, and we are taking that part in the laboratory. I'm going to test that. First thing. Second thing, here the soil mass is in compacted form. Here the soil mass is in compacted form, but I'm going to take that soil mass in a disintegrated form. There is a disturbance to the soil mass. So tell me, your laboratory test will give the exact solution of exact strength that is available at the ground surface?
no, sir.
No. So that is what your soil mass is very, very sensitive. Is very sensitive. So whatever the property and characteristics and stiffness and strength on site is there, that you will not get in the laboratory. First thing. Second thing, like suppose your laboratory may be far away from your soil mass, your land, your proposed area, your proposed site. So what will happen? Like suppose you are taking the sample from a site, and you have to carry that sample to the laboratory. There is a greater distance between them. Okay, so here the moisture content will be different. If I am going to carry that soil mass in the laboratory, the same moisture content you will get.
No, no, sir.
No, there will also be change. Here in this surrounding temperature, surrounding situation is totally different. That will not be available in disintegrated form in the laboratory. So these all are the complications. There are so many complication for finding out exact property of your soil mass. And as I told you, your foundation is not carrying the load. what foundation is doing? Tell me fast. What foundation is doing?
Transfer load.
Exactly. It is transferring the load to the subsoil. But most of the times, we are not taking the care about your subsoil, because this all important point is very important that I have covered just now. So finding out the exact capacity of your proposed land, of your proposed site, that is the first thing. All the things are later one. Design of the foundation, design of the superstructure, all the superstructural elements, that all are the secondary thing. Very primary thing is what we need to know: the capacity of your subsoil, capacity of your soil mass. That's why, like in comparison of all other safety factors, the safety factor for finding out the bearing capacity of the soil has suggested that it should be 2 to 3. Hello.
Yes, sir.
Why? Due to all these reasons that we have covered just now. So on site, what geotechnical engineer will do, whatever the capacity of the soil on site he will get after the calculation, after the testing. Like suppose the capacity of the soil he is getting what, 800 kilonewton. Hello. Suppose the capacity of soil is getting what, 800 kilonewton per meter square. So in soil investigation report, he will give you the capacity of the soil by reducing it by 3 factor of safety. So how much it will become? Hello.
So 260, approx 260.
260 almost. So it will give in your soil investigation report as 250 kilonewton per meter square. So
Excuse me, can you repeat this, please?
sorry.
The voice is cracking.
Hello.
Hello, the voice is cracking. Can you please repeat it? How
Nirvana.
it
Wait.
yes. 250 kilonewton. How it
Is it possible? Is it visible? Hello.
Yes, sir.
Now I'm
is
audible.
visible. Oh, yes.
Okay, so very first thing is what, the on-site, suppose the geotechnical investigator or geotechnical engineer is getting what, the capacity of the soil after testing, after manual calculation, when everything is right, when everything is correct, he is getting what, the bearing capacity of the soil, like suppose 800 kilonewton. So in soil investigation report, he will give you only 250 kilonewton per meter square, because he is going to take the factor of safety over your soil mass, or your capacity of the soil mass. And why this much higher factor of safety where is going to be taken? Due to all the reason that we have discussed just now. Because what actual thing is different, but we are going to take so many assumptions over all that actual things. That's why it is recommended that we need to take higher factor of safety for finding out the bearing capacity as first thing. Second thing, what, everything is going to be act over your soil mass. So you need to take the more factor of safety. Okay, if the soil is going to be fail, your entire structure is going to be fail. If your soil is stable, so your entire structure will be stable. Okay, so this is a very important point we have covered. Very important point. Is that all okay?
Okay.
Yes, sir.
Hello.
Please continue.
Yes, sir. It's okay, sir.
Okay, very good. Now the next thing is what, as you know that whatever the load you are going to put over the foundation, it is going to be transferred to the subsoil. So what action is going to be what action is going to be happen over your soil mass, that we need to know. So it is what, the load you are going to act over the soil mass, that is creating two kind of stresses in the soil mass. Hello. They are going to create two kind of stresses. One is going to be act at the interacting surface of your foundation and your soil mass. It is what, the stress is going to be developed at the surface of the foundation. At the surface of the foundation from the soil mass, first stress is going to be developed, and second stress is going to be developed inside of the soil mass. Hello. So one is will be what, at the surface of the foundation, we are going to call it as contact pressure. Hello. due to action of
Yes,
the
sir.
load from the superstructure through the foundation to the subsoil. So soil, what will do, the two things will happen in the soil mass, with the soil mass. One is inside of the soil mass and one is reaction from the soil mass. So the reaction from the soil mass at the surface of the foundation, we are going to call it as contact pressure. Can you repeat it once? Hello?
Yes, sir.
Hello?
Contact pressure.
Contact pressure. Another thing that is going to be developed inside of your inside of your soil mass, that will be what? Stresses developed inside of soil mass. Stresses developed inside of your soil mass. One stress is going to be developed at the contact surface of your foundation and soil mass, that is called as contact pressure. Very very important point. Just come back. So as you all know that, like Newton's third law of motion, what is there? Every action and reaction should be equal and opposite, but for what? For the stable and equilibrium structural response. Hello, Newton's third law of
Right.
motion. I hope you all know very well. What is the Newton's third law of motion? Hello.
So every action has an equal and opposite reaction.
Exactly. Every action will have the equal and opposite reaction. So same thing is applicable here. Very basic concept. Whatever the load is going to be acting over the subsoil, your soil mass should capable of reacting to that load. But the question is what? Try to understand. Suppose the foundation is there and the subsoil is there. Subsoil mass is there, so the action is going to be act over the soil mass. So soil will react to this action, and that is called as upward soil pressure, and is going to be acting at the surface of your foundation. Now as I told you, whatever the action is there, there should be equal reaction. There should be what? Equal reaction. But in some case, suppose the equal reaction is not there, your upward soil pressure is more than that of your action. Your upward soil pressure is more than that of your reaction. Sorry, your reaction is more than that of your upward soil pressure. Sorry, whatever the load you are going to put is less than that of your upward soil pressure, means your upward soil pressure is more than that of action. So what will be there? There will be lifting of this foundation. Right or wrong?
Yes, sir. Right, sir.
Okay, it will be one thing. Another thing will be what? If your upward soil pressure is less but the action is more, so what will be there? Settlement will be there. Am I right or wrong?
Yes, sir.
Settlement. And in the first case, lifting will be there, uplift will be there. So our intention is what? We need to have the equilibrium state, equilibrium condition. We need to have what? Equilibrium state or equilibrium condition. For that, whatever the load you are going to put, that should be what? That should be that should be your upward soil pressure and your action should be equal. Then stable condition will be there. But in some situation, up to a certain extent, settlement we will allow. Up to a certain extent, we will allow the settlement, but in no any case for the design of foundation, we are going to allow the uplift. What possibility is there? Your upward soil pressure will be less. Your upward soil pressure will be less, so that what? Some settlement we are going to allow. Some settlement we are going to allow, but uplift in no any case we are going to allow. Clear? Hello?
Yes, sir.
Okay.
Yes, sir.
Second thing, like suppose so whenever, so first thing is what? Contact pressure. So the distribution of the contact pressure is based on the stiffness and rigidity of your foundation and your subsoil. It depends on the two things. The contact pressure at the surface of your foundation is depends on the rigidity and stiffness of your soil mass. So rigid foundation may be there, flexible foundation may be there, clay soil will be there. So there are so many shapes of distribution of the contact pressure is there and settlement is there. So I'm not going to discuss about the theory. Here we need to understand the concept. So whatever the contact pressure is going to be act at the surface of your foundation is depends on, just remember, rigidity of your foundation and stiffness of your soil mass. So very first thing is what? Contact pressure. So knowing the actual contact pressure is the first thing. Second thing, the stress is going to be developed inside of your soil mass. Okay, this contact pressure is very important to calculate. This contact pressure is very important to calculate because this contact pressure is required and important for finding out the how much bending moment is going to be generating at in the foundation. Due to for this contact pressure, for this contact pressure or upward soil pressure, we need to design the foundation. Hello, you all are with me? Suppose the
Yes, sir.
foundation is there like this. Hello, and the contact pressure is like this. Hello. So the load coming from this side downward, the load coming from bottom side as upward. So there is the possibility of deformation of this concrete slab or foundation slab in this format. To maintain the stability of this, we need to design this foundation due to action of this upward soil pressure or this contact pressure. We need to design it for the bending moment. So to calculate the bending moment, how much bending moment is coming to the face of your column, we need to have the contact pressure. To know this how much shear force is there, we need to have the contact pressure. So to finding out for the flexural design of your foundation or for the shear design of your foundation, we need to calculate the contact pressure. Without of having the contact pressure, you can't calculate the movement, how much movement is going to be generating and how much shear forces are going to be generated in your foundation, that you can't do. So that is the importance of calculating the contact pressure. Hello, you all are with me?
Yes, sir.
Second thing, okay, first thing is very important. So for the design, we need to have the contact pressure. Second thing is what? Stresses going to be developed inside of your soil mass. Stresses going to be developed inside of your soil mass. So what will happen? Suppose you are going to put your foundation along with the superstructure or the column. So the stresses, the load is going to be transferred to the subsoil. So up to a certain depth, and over a large area, this earth mass will be under the pressure, will be under the stresses. There will be no effect beyond of this line. There will be no effect beyond of this line. The stresses is going to be developed due to action of this loading. It is going to be generating for this area only. If you are going to find out stresses to this point due to this loading, there will be no any stress. There will be no any effect on this soil mass. There will be no effect on this soil mass. There will be no effect on this soil mass. Only over a certain area or up to a certain depth, over a certain radius or certain radius or a particular depth, the stresses due to action of this load is going to be acting. This mass will be under the stress only, and this is called as what? Pressure bulb. Hello. So up to what depth we need to consider the stresses due to action of this loading. So at a depth from which, at a depth below which there will be no effect, stress more than of 20%. The stresses below this depth, very minor stresses will be there due to action, due to effect of this loading. Very minor stresses will be there in the depth, And if you are going to find out the stresses beyond of this pressure bulb, there will be no stress to this soil mass. So the thing is what, only this area will be under the stress, and this is called as what, pressure bulb. And when you come to this, so the what is the conclusion, why it is needed to discuss this theory part? Because if you are taking isolated foundation, so its stress will be up to a certain depth only, minimum depth only, and to a minimum radius only, to a minimum radius only. So this area will be stressed only. This area of the soil mass up to this depth will be stressed only. But when you are going to put two foundations very close to each other, so what will happen? The stresses is going to be developed here like this. The stresses is going to be developed here like this. So yeah, this part is okay. This part is okay. But it is this part of the soil, this depth of the soil or this area of the soil will be stressed twice. Some stresses from this foundation is coming to this part, some stresses is going to be is acting from this part, so it is heavily stressed. There will be the possibility of failure of this mass. Am I right or wrong?
Right, sir.
Are you getting my point? So that is the very important thing. That is what very important thing. That is what effect. That's why when you are going to design the foundation, especially for the design of the pile foundation or or pile foundation, pile cap, we need to have sufficient spacing between the two piles. We need to have what, sufficient spacing between the two piles. Why that there is a recommendation to maintain the sufficient spacing between the two piles. This the reason is actually this one, pressure bulb. The stresses due to this pile foundation will be like this. And if you are having sufficient spacing, so the pile this pile will have the pressure bulb like this. So there will be no overlapping of the stressed area. But if you are not maintaining a sufficient spacing between the two piles, so what will happen? The stress from this pile will be like this. The stress from this pile will be like this. So this area of the soil mass will be stressed twice. Hello. There will be the possibility of
Yes,
failure
sir.
of this soil mass. Getting or not, Rayan?
Yes, sir.
Yes, sir.
Okay. And as much as you are going to increase the width of the foundation, your area, the stress area of your soil mass is going to be increased. The stressed area of your soil mass is going to be increased if you are increasing the width of your foundation. Like suppose if you are going to talk about raft foundation, so stress area is going to be increased, your depth is also going to be increased, and your radius or area this width is also going to be increased. Okay, so that is the thing very important. Two action will be there over your soil mass. One is what, the contact pressure, another one is the stresses going to be developed inside of your soil mass, and these stresses is required to know the settlement in your soil mass. Hello. For finding out what,
Yes, sir.
settlement in the soil mass, we need to find out these stresses. To calculate the stresses, to calculate the settlement, we need to find out the stresses inside of your soil mass. And to check the stability of your soil mass, we need to check it. We need to do the calculation for finding out the stresses in inside of your soil mass. Okay, so this is what the very important basic concepts we need to understand. Is that all okay? Hello.
Yes, sir.
Okay, now next point, try to understand. Basically, uh, there are two types of foundation, you know very well. Can anyone guess what are the different types of foundation?
Yes, sir. Shallow and deep foundation.
Okay, basically there are two types of foundation. One is your shallow foundation, another one is your deep foundation. One is your what? Shallow foundation.
Deep,
Another one is what? Deep foundation.
deep.
So shallow foundation means what? It is with the depth of the footing is less than the width of the footing, or in other way you can call it as, you can say that if the width of the footing is more than the depth of the footing, at that time we are going to call it as shallow foundation. We are going to call it as what? Shallow foundation. And in a situation when the width of the footing is less than the depth of the footing, we are going to call it as what? Deep foundation. So here the depth of the footing, most of the time participants or students are confused. The depth of the footing, they are considering this depth. So this depth we don't need to consider. From the ground level to the base of your foundation, this we are going to call it as depth of your footing. Hello.
Yes, sir.
Okay, so what is the formula
Okay.
to calculate this depth? So this is what the load coming from the superstructure divide by density of your soil mass multiplied by 1 minus sine of angle of friction divided by 1 plus sine of your angle of friction square. So this is the formula to find out this depth. So this is what the depth at which the base of the foundation will be. So this is called as depth of foundation. It is this depth of the slab, depth of the foundation slab it is. So don't consider this one. Is that all okay? Hello.
Yes, sir.
Okay. So this is what shallow foundation. This is the deep foundation. So under what situation and under what are the different criterias to find to decide what type of footing will be suitable for our proposed structure? That is the important question. Hello.
Yes, sir.
Under which situation or for which case we need to go with the any particular type of foundation. So what are the criterias are there? What are the criterias are there that we need to understand? So there first shallow foundation is there. So in shallow foundation, what? Simple pad footing will be there. Simple pad footing there, combined footing is there, raft foundation is there, like pad footing, or I can say isolated footing, isolated footing. Second is what? Raft foundation, raft foundation. These all are what? Your shallow foundation. These all are what? Your shallow foundation. But when you come to what? Deep foundation. So deep foundation is your pile foundation.
Hello?
Hello.
Hello, excuse me. Can you
Yes.
please show us the pad foundation? Please.
Sorry.
Pad foundation, pad.
Pad foundation. Pad footing.
Pad footing. Can you please show us a picture or something?
Wait, sir. We will come to that point. Anirban, sir.
Yes, thank you.
Okay. Yeah.
Okay.
So shallow foundation will include your pad footing or box footing or normal footing, pad footing, shallow foundation. Second will be the raft foundation. Will be what your will be your shallow foundation. When you come to the deep foundation, your deep foundation will be your piles and caissons. There will be, and there are so many different types of the deep foundation. Okay. So we will come. We will discuss one by one what are the different types of the foundations. So in shallow foundation, what? Simple spread footing is there. We are going to call it as a pad footing. We are going to call it as pad footing. We are going to call it as normal footing. We are going to call it
नॉर्मल
as
फुटिंग को ही
box
पैड
footing.
फुटिंग बोलते हैं.
Sorry.
नॉर्मल फुटिंग को ही पैड फुटिंग बोलते हैं.
उसी को पैड फुटिंग कहते हैं, उसी को लाइक बॉक्स फुटिंग कहते हैं, उसी को सिंपल आइसोलेटेड फुटिंग कहते हैं. ओके.
ओके ओके.
Yes. Now it will be what? Simple spread footing. But in isolated foundation, another type of footing is there. Isolated means what? The single footing, one footing for single column. That is called as what? Isolated foundation. It is a separate footing. There will be it is going to carry the stresses for the for only one column. The load is going to be act to this foundation through the one column only. Through the one column only. So it is what? Isolated foundation. But in isolated foundation, there are two types of the footing. One is the stepped footing. Another one is sloped footing. Another one is what? Your sloped footing.
Slope.
Then if your foundation is to carry the stresses or loads from the two columns, we are going to call it as combined footing. Two columns or more columns, more than two columns if is there, so we are going to call it as what? Combined footing. So the isolated foundation will include your box footing, normal footing, it may be a stepped footing, it may be sloped footing. When you come to the two columns, so that foundation we are going to call it as combined footing. Hello. If
Yes,
Yes,
RCC
sir.
wall is there, and if the shear wall is there, uh, if any retaining wall is there and you want to put the foundation for that, that is we are going to call it as wall footing. We are going to call it as wall footing. Then there is a strap footing. When there is a one type of foundation, this is also you can call it as combined footing. This is what strap footing. Then when your foundation is going to be carry the stresses from the number of column, more than 3 4 5, and there are different rows of the columns, that we are going to call it as raft foundation. We are going to call it as what? Raft foundation. And when you are going to put when any column is there, which is for that we need to provide the deep foundation, we are going to call it as pile foundation. So these are the different types of the foundations are there. Now we will look at like under which situation, which type of footing will be acceptable. Hello.
Yes,
Under
sir.
which situation, which type of foundation we should use, that we need to understand. So there are so many parameters and criteria that are there. Based on that we are deciding the type of the foundation. Can anyone tell me what are those criterias?
Yes, sir.
What are
Soil
those?
bearing capacity.
Soil,
Loading and soil
One by
property.
one, let me know one by one.
soil bearing
पहला
capacity.
फैक्टर है लोडिंग
पहला factor बोलो,
लोडिंग
बोलो।
और दूसरा है सॉइल का कंडीशन क्या है, सॉइल की कैपेसिटी क्या है.
Okay, what is the capacity of soil? Okay.
यस सर. और लोड कितना आ रहा है और बिल्डिंग किस तरह का है.
बिल्डिंग किस तरह? ओके।
आपको प्रेशर जो बल्ब दिखा है वो स्ट्रेस बल्ब में आ रहा है या नहीं. थर्ड है आपका सॉइल का बियरिंग कैपेसिटी कितना है उसके ऊपर. फोर्थ एटमॉस्फेरिक सिचुएशन.
Based on atmospheric situation also. Okay, one other thing also there. Most of you are missing that.
Sir, water table, sir.
Sorry,
Water table, sir.
water table. Yeah, that will also be one factor. Okay, so there are so many factors are there. Based on that, we are deciding the type of foundation. So very first, the subsoil condition. Very first is what? The subsoil condition or the bearing capacity of the soil on the proposed site. So if your capacity of the soil near the ground surface, if there is an adequate capacity of the soil near the ground surface is there, at that time simple isolated foundation will be okay. Hello. If the load is not much more, if the load is not much more that is coming from the superstructure, plus the capacity of the soil near the ground surface is adequate, at that time we can go with the simple isolated foundation. Hello.
Okay.
यस सर.
First thing.
Can you
Now,
mention the load?
when I'm going to look into when I'm going to look to these isolated foundations, so here the simple isolated foundation. So what is the use of this stepped footing? What is the use of this sloped footing? That will be question. Like, okay, I have decided that I have to provide the isolated foundation because my load is less, and my bearing capacity is also adequate. So I have to go with the simple isolated foundation. But when I'm going to look here simple isolated foundation, so three options are there. One is your box footing simple, second one is the stepped footing simple, and third one is the sloped footing. So with which footing we should proceed? So let's try to understand. If like a simple foundation you are taking, if the load is adequate and the capacity is also adequate, and the design demand the sufficient depth of the foundation, then only you can go with the simple isolated foundation pad footing. But when you are going to do the calculation and suppose the design demand to provide the very large depth, suppose the design demands very large depth to satisfy the punching shear criteria, to satisfy the one way shear criteria. In that situation, what we need to go with the stepped foundation. Hello.
Yes, sir.
Yes, sir.
In another situation, like suppose if the same situation is there, suppose very large depth is required, very large depth is required, okay, near the column face. So at that time we can go with the sloped footing also. So these two types of foundations where we are referring based on the situation, based on the requirement, when the depth of the footing requirement is very very large. So to achieve the economy in your design, we are going to choose either stepped foundation and sloped foundation. So one another parameter we are going to take out from here. There is a one another parameter to decide the type of foundation is what? The economy in the construction. Hello.
Yes, sir.
Yes,
Yes,
sir.
sir.
Very very important parameter. Very very important parameter. Economy in the construction. The cost of the construction is the most important parameter on which or based on that we have to decide the type of foundation.
Farmer.
Okay, so what type of foundation you should use, that is also depends on what the economy and the cost of the construction. So one thing will be there. Okay, come back. So very first is what? Bearing capacity of the soil. So if your bearing capacity of the soil near the ground surface is adequate and load is also moderate, load is also adequate, so in that situation we can go with the simple isolated foundations. Simple isolated foundation. In simple isolated foundation, different types are there, like simple box, stepped and sloped. So we have discussed that to achieve the economy we are looking for the stepped and sloped footing. If there is no concern of the economy, then we can go with the simple isolated foundation as box footing, normal footing. Now your combined foundation raft foundation is also, your combined foundation raft foundation is also what? Shallow foundation. So if your bearing capacity of the soil near the ground surface, if the bearing capacity of the soil near the ground surface is adequate, so you can go with the isolated foundation. So the situation when to use the combined footing, when to use the raft foundation, that all we will discuss later. So here the discussion is what, like in which situation you can go with the in which situation you can go with the shallow foundation, that is what? Bearing capacity of soil. Is that all okay?
Okay, sir.
Okay.
Yes, sir.
Second, here we are going to decide either shallow foundation or deep foundation. That is the discussion. So don't ask me like, sir, in which situation we have to use the strap footing, in which situation we have used the combined footing. That I will cover all these things later. Okay? Hello.
Okay.
Okay,
Yes,
sir.
sir.
Okay. Now,
Yes, sir.
here discussion is what? Under which situation you have to go with the shallow foundation, under which situation you have to go with the deep foundation. So very first about the bearing capacity of the soil. Sometimes what will happen, near the ground surface the bearing capacity is very very low. Near the ground surface bearing capacity is very very low. Then we need to do the more exploration to find out the bearing capacity to next depth. Okay, if we are not getting the capacity as per our requirement, then we will come down once more. Then we are going to find out the capacity at this level. If we are not getting as per our requirement, then we will go down. So now ultimately, if suppose it is, if you are planning to provide the foundation at this level, so what? Obviously you need to provide the deep foundation. Getting or not? Hello.
Yes, sir. Got.
We need to provide
Yes, sir.
what? Deep foundation. Shallow foundation will not be there. So if near the ground surface, if the bearing capacity is okay, you can provide the shallow foundation. If the near the ground surface capacity is not much more, we need to go to the deep and deep. And then if we are going to provide the foundation, so you need to provide the deep foundation, or we can call it as pile foundation. First thing. Second parameter will be what, on which the type of foundation, selection of a type of foundation will be depends, like your loading, the stresses coming from the superstructure, the stresses coming from the superstructure, that is what, another parameter. So the load on foundation. So if your structure is low rise, if your structure is low rise and it is over a large area, if the structure is low rise and it is over a large area, try to understand, for low rise building which is extended over a large area, the loads or stresses concentration is relatively low. The loads or stresses concentration is relatively low. So the shallow foundation is providing. We are providing what? Shallow foundation. Suppose example will what, your school building. Hello, your any kind of public
Yes, sir.
building. So you know very well the any kind of public building will be what, over a large area. Like let's consider an school building or row houses you can consider. So it is going to be distributed over a large area and only 1 and 2 floors are there. So it is low rise structure which is going to be distributed over a large area. So what will be there? Stresses will be less going to be act over your soil mass through your foundation. So in that situation, shallow foundation will be okay. Are you getting my point? Hello.
Yes.
Yes, sir. Excuse me,
Like
sir.
low rise commercial building is there, low rise residential building is there. Okay, any public
Excuse
building
me,
is
sir.
there. So this is all are what, low rise structure. So stresses will be less, loads will be less, and the sufficient capacity will also be there. Okay, sufficient capacity of the soil mass, if suppose you are not getting, suppose the bearing capacity is is not much more, it is less, but the load coming from the superstructure is also less. So we don't need to worry about, both the things are in same proportion. So we can accept here, we don't need to go for the deep foundation, we can provide the shallow foundation. Clear? Hello.
Excuse me, sir.
Yes.
सर एक्चुअली स्कूल बिल्डिंग है तो उसका स्पैन तो लंबा लंबा रहता है और उस पर लोड भी तो ज़्यादा आता है ना, क्योंकि लाइव लोड उस पर ज़्यादा रहेगा स्कूल बिल्डिंग की वजह से, उसका स्लैब का भी थिकनेस
कितना
ज़्यादा
ज्यादा आएगा
रहेगा।
लोड आपका? इतना ज्यादा मैटर नहीं करता है ना, कितना ज्यादा आएगा आपका लाइव लोड? ठीक है ना?
लाइव
हेलो
लोड तो 3-4 आ जाएगा ना कंपेरेटिव।
जावेद जी, कितना ज्यादा आएगा लोड?
जी सर,
दैट इज
मैं
नॉट।
बोल रहा हूँ
कितना
कि
फ्लोर
स्पैन
होता है
अगर
आपका?
लंबा
पब्लिक बिल्डिंग
रहे।
आपने देखा होगा, स्कूल का स्कूल बिल्डिंग आपने देखा होगा, कितना होता है? 1 फ्लोर 2 फ्लोर
हाँ सर,
मैक्स।
2-3 रहता है।
ओके, सो वहां पर हम लोग आइसोलेटेड फाउंडेशन के साथ और कम लाइक ठीक है, थोड़ा ज्यादा भी होगा तो इज इट नीडेड टू गो फॉर द डीप फाउंडेशन? कैन यू प्रिडिक्ट?
यस सर।
नो नीड टू गो फॉर द डीप फाउंडेशन। आर यू गेटिंग जावेद?
जी सर, सॉइल ये एसबीसी बहुत अगर लो रहा तो जाना पड़ेगा ना।
हाँ, दैट इज डिपेंड, बट अभी हम लोग बात कर रहे हैं किसकी? लोडिंग की। वो पैरामीटर तो हम लोगों ने पहले ही कवर कर लिया। सॉइल की कैपेसिटी, अगर कैपेसिटी आपका वीक है in respect of your loading or in respect of your action, anyhow you need to go for the deep foundation। वो पैरामीटर हो गया जावेद जी।
ओके सर।
अब बात कर रहे हैं लोडिंग का। सो वी आर गोइंग टू वैरी द लोडिंग एंड वी आर गोइंग टू कंसिडर सफिशिएंट bearing capacity of the soil is there। Okay, so in that situation what, the loading from the low rise structure will be less and it is distributed over a large area. So what stresses is going to be distributing and it is not going to be concentrate. So that's why you can provide the shallow foundation. But on the other hand, if you are going to look any big project or very high rise structure is there, so what, the load is going to be concentrated over a small area. Hello.
Yes
The
sir।
load is going to be concentrated over a small area. So in this situation what, at a particular point the intensity of the loading is very high. the intensity of the loading is very very high, and suppose the bearing capacity of the soil you are getting as normal, but bearing capacity of the soil here it is okay. In the previous case, when the shallow low rise building was there, in that situation what we are having, suppose the bearing capacity we are getting 250, here also we are getting 250, so the bearing capacity of the soils we are getting same, but the problem here is what, very very high intensity of the loading is going to be concentrated at this particular point. Hello,
Yes, sir. Right.
Wajahat, are you there?
Yes, sir.
So at this particular point, very very high intensity of the loading is coming. Although for the other situation where the low rise structure is there, so loading here coming what, very very high. Let's suppose 10,000 kilonewton force is there. How much? 10,000 kilonewton force. And here 1,000 kilonewton force is there, and bearing capacity is 250. So in this situation, I can go with the shallow foundation. But I'm
Yes,
going to
sir.
talk about here where the bearing capacity is 250, but the intensity of the loading is 10,000. Hello.
Yes, sir.
Here you are getting the good bearing capacity. Suppose here getting 250. Here you may get as 300 just for example, but still very high intensity is there. So you can't put a isolated foundation or any other type of foundation, except we need to provide the deep foundation. So first parameter is your bearing capacity of the soil, second parameter is your loading, getting load on the
Yes, sir.
foundation coming from the superstructure. Is that all okay? Hello.
Okay, sir. Okay, sir.
Then other factors and parameters are there to decide the type of foundation is what, budget of the building. What budget of or cost of construction the owner is going to be afford. Based on that criteria, you need to go with the type of foundation. So try to understand, deep foundation. Deep foundation is very very costly type of the foundation. Hello. If you are going to build any structure, so the cost of the construction of the superstructure means, if suppose any structure is there, hello, you all are with me, very important point. Hello.
Yes, sir. Yes, sir.
If you are going to design the or you are going to construct the deep foundation for any structure, like suppose the cost of the superstructure is whatever the cost of this construction of the superstructure, your cost of building your foundation will be twice of that. So whatever the cost is required to construct the deep foundation or pile foundation, the half of that with the half of that cost you can build the entire superstructure. Hello, getting the point? How much costly your deep foundation it is. Hello.
Yes, sir.
Hello.
You are getting.
So your deep foundations are very very costly foundation. So whatever the, if any building if you are taking, and if you are going to build the deep foundation as a pile foundation, so the whatever the cost is going to construct the deep or pile foundation, with the half amount of that cost you can build the entire superstructure. Hello, are you getting point? So if the budget is also one important parameter, the construction is cost of construction is one important parameter, so that you need to look out what type of foundation you have to choose, either shallow foundation or deep foundation. Then other factors are there, need of the client, what type of foundation means he want to prefer. Then environmental considerations are there. Marginal safety is also one important parameter. Hello, marginal safety, like suppose in future there is a plan of extension of the superstructure, like suppose right now the owner want to build G+2 building. Hello. Hello.
Yes,
Yes,
sir.
sir.
Yes, sir.
Suppose the owner want to build G+2 building in this year 2022, but he's saying that what in future, like in 2025 or up to 2030, I will extend 2 floor more above to this structure, G+2 building. So extension will be there. So while doing the design, you need to take the margin for 2 other floors. Are you getting my point? Hello.
Yes, sir.
Yes, sir.
So that also you need to take into consideration for deciding the type of foundation, marginal safety, risk level is also another parameter. So life of the structure is also one of the parameters. What life you would like to have for the structure. If your structure is very important, so you need to give more importance to the foundation design. If your structure is not much important, accordingly you need to give the importance to for the design of the foundation. And if your structure is temporary, so you can design the foundation accordingly. So deciding the type of foundation, there are so many important parameters are there, but amongst them the three major important parameters are: first is your what? Hello. Bearing capacity of the soil, right? Another, the load coming from the superstructure loading, and third one is what? Hello. Cost of the construction. Hello. There are so many other parameters are there, factors are there. Amongst them, we need to concentrate about these three parameters. That is the most important. We need to have the sufficient bearing capacity so that we can provide near the ground surface, so you can provide the shallow foundation. If sufficient bearing capacity is not there, we need to look for the deep foundation. And if the loading is very high loading is there, we need to go with the deep foundation. If the loading is moderate, then you can go with the shallow foundation. And about the costing, we need to decide the type of foundation. Is that all okay? Hello.
Okay,
Yes,
sir.
sir.
So yeah, so this is all about today. Okay. We'll start the later discussion by tomorrow. Okay.